All right, let's take a look at one of these buffer ice tables. Now this problem introduces a couple extra steps that we're building off of previous terms. First thing is we have to convert our salt, or our conjugate base, NaCH3COO, sodium acetate, into moles and then into molarity. Notice we have molarity for our acid, so right here, but we have grams and milliliters, so this would be 0.5 milliliters. So the first thing we have to do is find the molar mass, which is 20 grams multiplied by 1 mole per 82.03 grams. Now that's going to equal our moles, which is 0.244, and then we put that over our liters. Molarity is moles per liter, so 0.55, and we get 0.488. So we're looking here. Okay, so with that, now we have our initial molarity of our conjugate base. We also are given our initial molarity of our conjugate acid. So now we're going to fill this out to solve for pH. So here's our 0.488, our 0.150 goes here. We have to get rid of our H2O column because it is pure. We're going to start with 0 for our H3O plus, which means we're going to plus X. We're going to plus X here, and we're going to minus X here. So that gives us 0.15 minus X. Here we just have X, and then here we have 0.488 plus X. So this is our ice table. Now remember, our Ka expression is going to be dealing with when we're at equilibrium, so we want to put these in. Even though we're going to do X is small when we solve for pH, so we will eliminate these. We want to put them in this software in our Ka expression in our step 2 because it says do not simplify. So let's look at that. So we got 0.488 plus X on the top, and 0.150 minus X on the bottom. So here's our 0.48 plus X. We have just an X, and then we have 0.150 minus X on the bottom. So that's step 2. Step 3 is to solve for pH. To do that, we're going to cancel this X here, cancel this X here, and we're going to solve for X. So first thing I'll do is 1.8 to the negative 5th multiplied by 0.150. So I'm bringing this up over here. Then the next thing I'll do is divide by the whole thing by my 0.488. And that gives me X equals 5.53 times 10 to the minus 6. Now that's pH, right? If we go back to here, this X is equal to H3O plus, which will be how we represent pH by doing the negative log of that 5.53 times 10 to the minus 6, and I get 5.25 for my pH. 5.26 is what they get, and let's take a look. There we go. So important to have the right components in. You got to not simplify here, but you do simplify when you solve for pH.